Hello and welcome to this talk titled Docker and Spring Boot, What You Should Know. In this talk, I'll be covering how we can use Docker to effectively package and distribute your Spring Boot applications and services. My name is Kaushik Kotagal. I am a staff engineer at LinkedIn, and I'm also the creator of JavaBrains, a YouTube channel and a website where I have a bunch of courses available. The website is javabrains.io. And you can also look me up on YouTube. If you like this talk, there is a good chance that you're going to like some of my other content. So go to my YouTube channel and smash all buttons that need to be smashed over there. In this talk, I'm going to be talking about Docker with Java applications in general, how Docker helps Java developers and how all Java applications can benefit from Docker. And specifically, we're going to be looking at how we can Dockerize a Spring Boot application. And we're going to do this step by step in this talk. We're going to do progressive improvements, and I'm also going to show you some options that we have at our disposal to Dockerize a Spring Boot applications. But before we get started, I want to talk about why bother with Docker if you're a Java developer. Because traditionally, the promise of Java has been write once, run anywhere. And the way in which Java has been keeping up that promise is using something called a Java virtual machine. The point of the Java virtual machine is you have portability for your Java applications, and no matter where you want to run your Java apps, you should be able to do it because the virtual machine kind of provides that layer of abstraction. But now, let me ask you this. I want to ask you if it is actually fulfilling its promise of write once, run anywhere. So I'm going to have this simple Java programs, probably the very first program that Java developers learn, something that prints hello world to the console. Or does it? Now, what is the console output if I were to run this Java program? If I were to say, what's the output? The answer is obvious. You would probably get hello world. But it's not guaranteed. You could potentially get Java command not found in the output. You could potentially get a memory error. You could potentially get an error about file permissions. Well, Java is write once, run anywhere if that anywhere happens to have the necessary conditions for a Java application to run, right? There needs to be Java installed. There needs to be the Java path set. There are a bunch of things that need to happen, okay? So without that, there could be so many other things that could happen when you run that simple hello world program. Okay, so while Java is technically write once, run anywhere, the promise is truly fulfilled if you couple Java with Docker, right? So you compile your Java class, stick it into a Java-based Docker container, add the right entry point to your Docker container, and now you're good, right? Now you have a unit of deployment that is your Docker image that you can deploy and run anywhere, and you know that it's going to work exactly like you would expect it, right? So typically in Java, the unit of deployment has been, you have a jar where you could create a jar, package a jar for your application. You're done with deploying and, you're done with developing an app. You want to deploy it somewhere, you package it as a jar. Traditionally, you've been doing that, right? Or you have a var for web applications, or EAR. Nobody uses EAR now, but it used to be the package of deployment, the unit of deployment for enterprise applications. These three still leave a lot of variables, which is like you need to have the right environment for something to run, right? For jar, you need a Java installation. For var and EAR, you need to have the right servers installed and running. So there's still a bunch of variables here. And this is where Docker image as a unit of deployment comes in. Docker image kind of takes care of making sure all the right software is installed and configured, so you don't have to worry about that, right? So Docker is useful as a result for most Java deployment scenarios. You're working on a Java application, you want to deploy it somewhere. It's kind of like a no-brainer to package it as a Java, as a Docker image, and then have that be the unit of deployment. So it's good in general, but it is vital, in my opinion, when it comes to microservices, right? Typically, microservice architectures tend to have sometimes 10 Java applications, sometimes hundreds of Java applications. Now, all of these applications need to be deployed. They tend to be cloud deployments often. And then the nature of these deployments is it has to be repeatable. It has to be versioned. And you want to have some way of controlling the environment and have it be a part of your source code. And this is where having this be in a Docker file and have the unit of deployment be the Docker image is super duper useful. So Spring Boot is probably the most common technology when it comes to building microservices in Java today, right? It's like overwhelming majority of users building microservices in Java use Spring Boot today. And Spring Boot actually works really, really well with Docker, like peanut butter and jelly, like chai and toast. It's a good coupling of technologies. And it's also super easy to get started, right? So what I'm going to do is I'm going to walk you through the process of Dockerizing a Spring Boot application. And we're going to do it iteratively, and we're going to add in concepts and understand these concepts as we go, right? Typically, when you're distributing a Spring Boot app, what you get is a jar file. It's what's referred to as a fat jar. The jar file contains your application, your Spring Boot application. It also contains the environment that's necessary to run it, the servlet container that's necessary to run it specifically, like Tomcat. It's bundled in with the jar file, and that's why it's referred to as a fat jar. So in order to build a Spring Boot application, what you typically do is run the Maven command with the package target. If you're using Maven, you have a Gradle equivalent for this as well. So when you run this command, Maven is actually going to package your Spring Boot application and create this fat jar for you, all right? Now, when you do this, you are going to you just run Maven W. Maven W is a Maven wrapper, which kind of comes with the starter Spring Boot application that you get from start.spring.io. You get this jar file, this fat jar, which is going to sit in your target directory. All right. Now, once you get this fat jar, you can run that Spring Boot application by doing java-jar, just like you run any Java jar file. You do java-jar and then your location of the jar file that is created. Now, how reliable is this method? Well, this has the potential problems as that first Hello World Java class that I explained, right? So you might run this, but again, there's no guarantee that the machine you're going to be running it on has the Java, runtime installed, right? The right version of the Java runtime installed. So there are a bunch of variables there. So in order to solve for those variables, what you can do is create a Dockerfile, right? Add a Dockerfile to your Spring Boot application and have it be, typical convention is have it be at the root of your Spring Boot app. And then here you can write instructions to create a Docker image from your Spring Boot app, from your Spring Boot build, and then have it be the unit of deployment which runs your Spring Boot application. All right, I'm going to walk you through this Dockerfile. The very basic starting point for the Dockerfile would be to first have a from, right, the root image. We use OpenJDK 17. I want to use Java 17. So I have that here. And then I'm going to have a copy command, which basically copies the jar file in the target directory, which we just saw, right? The Maven command packages and creates this jar file. You copy that over to app.jar in your image. And then you have an entry point, java-jar, app.jar, which is basically the way you ran your Java application. But now you're doing this inside a container, which is based out of OpenJDK 17. So you know that this is going to have Java 17 available for you. So you know that this is going to run exactly the way you want it to, all right? So here, this entry point is using the exec format, which is the square bracket with the strings separated by comma. And what this allows us to do is to say, well, if you want to run this, you are going to get a kill signal. If you want to do, like, you run this thing, you do a Control-C, the kill command is going to go to your Java command and not a shell. So that's the benefit of exec, and this is the recommended way of having an entry point over here. Okay, now when you do this, you can build your image by using the docker build command. I'm using the docker build over here. I'm doing the -t, and I give it a name, and then the dot to indicate that I want to run it with the Docker file that is in the current directory. And once that image gets built, I can run that image using Docker run. I'm also doing this port forwarding. So I know that 8080 is what is the default port in which the Spring Boot application runs. I'm mapping that 8080 to the 8080 of the host. And then once I run this, I'll be able to run and access the localhost colon 8080 and access that Spring Boot application that's running inside it, right? So this is, we've Dockerized Spring Boot now, right? So what we've done here is we used to have the Spring Boot application creating a jar file. Now what we've done is we've created a Docker file, and we are creating a Docker image, which is bundling the jar file inside it, right? We started out with a Java container, so we know that it has all the necessary things for Java to run. And now we put this jar file inside. This is all we did, right? And we have an image which runs our Spring Boot application because we added the right entry point, right? So the unit of deployment is now this image. It is no longer this jar file. Now, is this good enough? Well, the thing about Spring is that Spring has the ability to pass configs, right? You can pass configs as arguments when the application starts, or you can also pass as, with the Docker use case, you can pass it as run arguments, right? You can pass arguments to your Docker run command, and then that gets, passed to the Spring application. So here's an example. You have a port changed from the default 8080 to port 3000. And I do that by using this -- server.port equals 3000. This is a way for me to pass Spring configuration while the application is running, right? Dynamic configuration. And now when I do this, Spring Boot is going to accept it because I'm passing this as an argument to the Docker run command. And now I can map the port 3000 to 3000 because I've changed the port in which the Spring Boot application runs inside the image, inside the container. It's now changed to 3000. And now I need to port map to 3000, and this is going to work as well. I can pass in arguments to my Spring Boot application, which is running inside the container. Okay, very well. Now, sometimes the Spring Boot execution, the command line to execute the Spring Boot application becomes rather big, and you wouldn't want to have that all be in the entry point. And this is a common practice. Sometimes people just create a shell file. Here I have created this startapp.sh, and the entry point is basically just running the startapp.sh. And the startapp.sh contains java jar app.jar, okay? Just like before, but now we have one level of redirection. So now this shell file can contain more complicated commands, and you won't have to mess your Dockerfile and entry point line with so many other extra arguments and parameters or whatever else. When you do this, make sure you do the exec, okay? Because again, we want the Java process to be the root process. When you do the Control-C, when you run your Spring Boot application inside a Docker container, we want to be able to send the kill signal to the Java process, and you do that by using this exec command. The exec shell command basically says, I'm going to have this process run not as a child of your shell process, it's going to have a root, which is where the exec notation gets its name, by the way. This is called the exec notation because there is an exec command which does pretty much what you expect the exec notation to do, all right? Now, when you do something like this works fine, but now you have a problem with the arguments, right? We were able to pass arguments like the port earlier. You can do that still by accepting these arguments over here, right? So I have Java options passed as an argument. I also can take any of the arguments passed to a Docker run by just putting this in my shell command. If I'm using a shell command, you need to be mindful of accepting arguments as well, because if you don't do this, any arguments you pass is not going to go to the Java run, because now you have a separate shell file which is doing this, all right? Okay, so the build and run process has, the way we've been doing this now is you have a Spring Boot build being run in the host, and the app run is in the container, right? All the while, when we do this, everything we've done so far assumes that you have run a Maven package command in your host machine. You have your jar available, and then the Docker process is basically just bundling it into an image and then having that image be the unit of distribution. Now, can we do better, right? Here we are assuming that the host has Java installed, right? Can we have the build run in a container too? You already have a Java container, right? So why not use that to not only run the Spring Boot application, but also use a Java container to actually build your Spring Boot application? Well, that's possible. Here is an example of doing everything inside a Dockerfile. Okay, what am I doing here? I have a from OpenJDK 17, just like before. But now here I'm not assuming that the Maven command has run and a jar file created, okay? So I am choosing a workdir as /app, right? All the commands further on is going to run in this app directory. And now I'm copying all the necessary files for Spring Boot, right? I'm essentially copying the Spring Boot project inside that container. And now I'm running .mvnw package, right? This is the package command. I'm not running in the host anymore. I'm running it inside the Docker container as a part of the creation of a Docker image, right? So now I don't have to assume that the build has happened before. I'm doing this when the Docker image build is happening, right? And now I run this thing. I'm copying the jar file to app.jar as before. This part hasn't changed. And then I have the entry point as before. Again, this part hasn't changed. The only thing is, rather than just copying the jar file, I'm creating the jar file during the image creation process, right? This works fine, but now we have a problem. This is going to result in a huge image, right? You have copied all the source files, which are not necessary, right? After you've created the jar, these things will either have to be cleaned up. Well, you cannot really clean up because each command here is a separate layer. You've introduced all these different layers here. How do you solve this? Well, we can solve this with Docker using multi-stage builds. Multi-stage builds allow you to create one image with the stage in which you need it, right? And you want a jar file created. Well, you use one stage for creating the jar file and create another stage where you're just picking the jar file from that image and creating a new image without anything else that was going on in that other image. Let me explain. So here is the first stage. In this stage, I don't plan to take this image and use it for running a Spring Boot application. This stage is primarily concerned with creating the jar file. So I have the from OpenJDK 17, but I'm giving it a name. I'm calling this the build stage, okay? And everything else, just like I just explained, I'm copying all the files and I'm running the mvnw package and I'm putting this jar file that's generated inside app.jar, all right? And then I'm not using the same image for running, right? I'm going to create another image, right? I'm going to have another from OpenJDK. But here what I'm doing is I'm copying that app.jar from that build stage step, which has the app.jar, and I'm placing that into the current directory, which is dot over here, right? app/app.jar, because the workdir is app and app.jar is created inside it. I'm copying that file into the current directory and I'm having an entry point over here. So basically this becomes an intermediate image, which was necessary for the creation process, but it is not going to affect the final result, Spring Boot image. So this is super handy. So we've looked at a bunch of different iterations of creating a Spring Boot image using Dockerfile. Now, the thing about these images are they're likely to be the same process no matter what Spring Boot application you have. Like everything we talked about really wasn't impacted by the Spring Boot application that you were building, right? It's most likely to be the same. And you have some common patterns and best practices by the industry that you want to leverage, right? So if you want to do that, there are some Maven and Gradle plugins that allow you to do this and not have to write the Docker file yourself, all right? So in this way, you basically have the Docker step as a part of your Maven process rather than the Maven being a part of your Docker process, right? You're kind of flipping the balance a little bit over here. So there are a bunch of Docker plugins. So there is the Spotify Maven plugin, which allows you to create, Docker images in the Maven step. You have Palantir Gradle plugin, and my favorite, the Jib plugin, the Google Jib plugin, which is available for both Maven and Gradle. So with these plugins, what you do is just stick that plugin configuration in your Maven configuration, right, in the pom.xml, and there is a Maven target which you run, and that is going to create your Docker image for you, all right? So this is the configuration for the Google Jib plugin, right? So here's the plugin's definition. I have the group ID and artifact ID and version, just like any other Maven plugin. But here is a to configuration, and I specify what the image name is. This is all that's needed. Actually, the Google Jib plugin doesn't really even need the Docker daemon to be running on your machine. Doesn't need Docker to be installed. It is going to take care of creating this image for you without having to use a Dockerfile or having a Docker installation on your machine. If you have a Docker file, it's essentially going to ignore it. It really doesn't matter. It has its own opinion of how to create a Docker image out of a Spring Boot application. That's what it's going to do. And in order to run it, you basically do maven compile jib Docker build. And this is actually going to load to Docker daemon if it's available, but you can skip it because Docker daemon isn't necessary here. You can actually have it publish your Docker image to a bunch of different places, right? You can have it published to the Docker Hub registry. You can have it published to the Google Container Registry, to Azure Container Registry. You can publish it to Artifactory. You get the idea. It's very configurable, and it can push your Docker image to a bunch of different places. So the Google Jib plugin, again, like I said, it doesn't require Docker to be installed. It's ideal for build machines where you're minimizing the amount of things necessary to be running on a build machine. You can have lightweight build machines for this process. It also auto-applies best practices. It has its own opinion of how a Spring Boot Docker image needs to be created. So it's going to auto-apply it. The disadvantage is you lose that fine-grained control over the process. If you have your Dockerfile, you can control how every step of the way what happens. But with the Google Jib plugin, it's kind of like you give it to it and it's like it does its magic, and you have a Dockerfile, a Docker image at the end, and you kind of lose that control. But depending on what you're looking for, this might be a really good option as well, right? So this is kind of like a tour of Docker and Spring Boot. What are the different ways in which you can create these images, production-ready images for your Spring Boot application? Once you have an image ready, you can push it to any container service, container orchestration service, or you have your own infrastructure which takes Docker containers and runs it. You kind of get the benefit of all of that by just using these steps to have the unit of deployment be a Docker image instead of a fat jar. Thank you for listening. Thanks to the Docker community for the opportunity to present this talk on the Docker's birthday. I hope you found this helpful.